So once again, a quick little video to help you as you're moving through the Unit 1 topics. For this video, I would suggest that this is a working practice that you're doing. So you've got your paper, your pencil, your calculator, and you're working through these problems. You're pausing the videos and working the problems and checking your answers. All right, so this is a great time to read this problem, pause this video, and see what you can do. All right, so as I'm looking at this problem, I'm noticing that there's a lot of information here. I see I've got a mass, and then I see I've got a graduated cylinder with 20 milliliters of water. I put the object that weighs 45.71 grams into the cylinder, and the volume goes up to 48.3. So I'm going to take that 48.3, the final volume here, and I'm going to subtract my initial or starting volume, which was 20.0 milliliters. Now keep in mind, 20.0 has 3 significant figures in it, so that is super important. So that way, since I'm adding and subtracting here, the tenths place is my smallest measurement of significance. So that's where I would need to round to. And so I see that my volume here for this object is 28.3 milliliters, still with 3 significant figures. And so this number here is significant. And this question is asking for the density. Well, I know the density formula, so I can go right ahead. And of course, here's our density triangle. By the time of our first test, you will have wanted to have used this triangle so many times that you know exactly what it is. All right. And so our density is, there's our mass divided by our volume. And we come up with an answer like this. Notice that our units are, since they don't cancel out or diagonally drop, they're coming right along for the ride. And then I just need to round what I got for my final answer to 3 significant figures. All right, so how did you do? I'm hoping you did really well. All right, here's another problem. Not a density problem, but a dimensional analysis problem. Probably shouldn't have even told you that. So great time to pause the video and see what you can come up with. All right, how did you do? Did you say that the cost of gold is $2,718 an ounce, and that 1 ounce is, here's your conversion factor, 1 ounce is 28.4 grams. Notice that our ounces here are going to cancel. And so we're just left with a little division problem. So you would go straight across the top and multiply 2,718 times 1 gives you 2,718. And then on the bottom, 28.4. And so simply divide those and you would come up with $95 a gram. Now notice, because there were 6 significant figures, because when they're buying and selling precious metals like gold, they do go out pretty much to the 10th and 100th even of a cent as they're doing that. So hopefully you did really well on that one as well. All right, so here's a question about a piece of turquoise. So again, another great time to pause the video and let's see how you did. There's a series of 3 questions here. And so see if you can do the first one, qualitative, quantitative. All right, so the qualitative observations describe the qualities of the turquoise, bluish green. It's a solid, that should say solid, not sold. And your quantitative observations are the measurements. And so we do have 2 measurements here of this turquoise. Now, how about intensive versus extensive properties? And so our intensive properties here are the density. The intensive properties don't depend on the quantity you have, or they just depend on the substance that you have. And so the mass would be extensive. That it would be an extensive property. It's going to depend on how much you have. So I kind of think of intensive as what is internal for this object. Again, there's our extensive property. All right, now how about the volume of this piece of turquoise? Can you do the volume? Once again, use our density formula. There it is. What do you come up with? Great time to pause the video. Hopefully you're using our density formula. Volume equals mass divided by density. As you're doing this, you're taking these two numbers. Now notice for the units, I would take this unit here and flip it up and take the reciprocal of it because we're dividing by a fraction. Notice that my grams are going to cancel out here. I'm left with milliliters, which is what I'm going to want for volume. And so I come up with 0.94 milliliters, of course, rounded to two significant figures. All right, here's another one for you. See if you can carry out these operations rounding to the correct number significant figures. Yes, there are some ones with scientific notation here. Of course, if you don't like scientific notation, you don't feel comfortable with it, you can always take these numbers out of scientific notation. All right, so what did you get? So the first one, I again type it into my calculator, 1.52 times 6.21. Second function, negative 3. And I came up with 0.00944, rounded to three significant figures. Remember, these leading zeros are not significant. All right, how about the next one? Now, for the next one, I took them out of scientific notation, so I got 6,210 minus 523, which equaled 5,687, and then I rounded that to the tens place. Since I'm adding and subtracting, the rules for significant figures are different, and there would be that 1 in 6,210 is my last significant figure, so I would have to cut everything here. So it doesn't matter that I'm adding that 3 at the end, except for that does help it round up. All right, and the last one. Hopefully you got 11.9, again, rounded to three significant figures. For the scientific notation, not significant. Those numbers are not significant at all. So again, as I'm typing this into my calculator, I'm going 6.21. Second function, EE3, divided by 5.23, second function, EE2. If you use the evil caret on your calculator, it will not work. It will not give you the correct answer. All right, so errors I noticed in the homework from homework 1, the homework and the review quiz. So one of the questions was, which zeros are significant? Well, so I see I've got zeros at the beginning of the number, zeros at the end of the number. The leading zeros are never significant. Now, zeros after a decimal place and after a number are significant. So these zeros here would be significant. So this number has 4 significant figures. And so I'm noticing another problem that I noticed was you were asked to, this wasn't the exact problem, but you were asked to add something like this and then round to your correct number of significant figures. So what did you get for that? Well, hopefully you're knowing that you're adding. And so we're looking for the decimal place. So I see that the hundreds here is my least significant figure there. I can see that I've got 3 significant figures here and they're going to the hundredths place. I see I've got 1 significant here and it's also in the hundredths place, but it's not really going to matter because 2,600 doesn't have a lot of significant numbers in it. And so you should have come up with something like 2600 round when that is rounded to the correct number of significant figures. So on all tests and quizzes, you're always going to round for this correct number of significant figures. And even on active chem, you will lose points if it is not rounded correctly. I hope this helps you as we're moving through Unit 1.